Hello everyone, this is Kalpana here. In this video, we're going to solve a differential equation using variation of parameters method. So let's get going. Problem: solve y double dash minus y equal to e power minus x sin e power minus x plus cos e power minus x, or d square minus 1 into y equal to e power minus x sin e power minus x plus cos e power minus x using variation of parameters method. So we are given a differential equation of order 2. Given differential equation, y double dash minus y equal to e power minus x sin e power minus x plus cos e power minus x. Consider as equation number 1. Now we can write y double dash as d square y by dx square minus y equal to the RHS part Now write d square y by dx square as capital D square y minus y equal to e power minus x sin e power minus x plus cos e power minus x. Now take y common from these two terms. We'll get d square minus 1 into y equal to e power minus x sin of e power minus x plus cos e power minus x. Consider as equation 2, which is in operator form. Equation 1 in operator form is equation 2. Say f of d into y equal to some function of x. Where f of d is d square minus 1 and r of x is the RHS part. Let's now write the homogeneous equation of equation 2. D square minus 1 into y equal to 0, consider as equation 3. Now we'll find the solution to this equation using the auxiliary equation, and later using the solution of homogeneous equation we'll find the general solution of the given equations or the given problem, we can say. Now coming to the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square minus 1, right? Let's replace the differential operator d by m, so that we'll get f of m equal to m square minus 1. Now the auxiliary equation becomes m square minus 1 equal to 0. We can write 1 as 1 square. So this is of a square minus b square form, so we can write this as m plus 1 into m minus 1 equal to 0. Now we equate each factor to 0. When m plus 1 equal to 0, we'll get m equal to minus 1, and when m minus 1 equal to 0, we'll get m equal to 1. So m equal to minus 1, 1 are the roots of our auxiliary equation. Therefore, m equal to minus 1, 1 are the roots to the auxiliary equation, which are real and distinct. The roots are real and distinct. We know that when two roots say m1 and m2 are real and distinct, then the solution to homogeneous equation looks like one constant into e power one root into x plus another constant into e power another root into x. So here we are taking C3, C4 instead of C1 and C2 because I want C1 and C2 to appear in the last general solution. Now coming to the solution to a homogeneous equation. The solution to homogeneous equation is y equal to C3 e power 1 root into x plus another constant into e power another root into x. This gives us y equal to C3 e power minus x plus C4 e power x. Therefore, y equal to c3 e power minus x plus c4 e power x is the solution to the homogeneous equation. Now, using this solution, we'll write the general solution to our problem. Let y equal to, now replace the constants or parameters with some functions of x, say a and b. Will get y equal to a e power minus x plus b e power x, be the general solution to our problem. Where a and b are functions of x. Now, we can compare the solution to homogeneous equation with y equal to some c3u plus c4v or just compare this with y equal to au plus bv, so that you'll get u and v, where u is e power minus x and v is e power x. See, u is e power minus x and v is e power x. Now, we'll find a and b using a dash and b dash. A dash is given by minus v into r of x by uv1 minus vu1, and b dash is given by u into r of x by uv1 minus v1. If you notice, you are having uv1 minus v1 in both the formulas, so we'll begin with uv1 minus v1. Later we'll find a dash a, b dash b. Finally, we'll substitute a and b in this equation to get the general solution to our problem. Now coming to uv1 minus v1. u1 is nothing but u dash, v1 is nothing but v dash, and u1 is nothing but u dash. This is equals to u e power minus x into v dash minus v into u dash. This gives us e power minus x into derivative of e power x with respect to x is e power x minus e power x into derivative of e power minus x with respect to x is minus e power minus x. You can write this as e power minus x into e power x minus into minus plus e power x into e power minus x. Since we know that e power minus x can be written as reciprocal of e power x, so we'll just replace e power minus x with reciprocal of e power x. We'll get right, where e power x gets cancelled and you'll get 1 plus 1, 2. Therefore, uv1 minus v1 equal to 2. Now coming to a dash. A dash is given by minus v into r of x by uv1 minus v1. This is equals to minus v e power x into r of x e power minus x sine e power minus x plus cos e power minus x by uv1 minus v1 is 2. This is equals to minus 1 by 2 into e power x into cos e power minus x plus e power minus x sine e power minus x. Okay. So we got a dash. Therefore, a dash equal to minus 1 by 2 into e power x into cos e power minus x plus e power minus x sine e power minus x. Now using this a dash, we'll find a. We have a dash equals to minus 1 by 2 e power x cos e power minus x plus e power minus x sine e power minus x. A dash is nothing but derivative of a with respect to x. The RHS part remains the same. Now let's separate the variables by taking differential dx to RHS. We'll get dA equal to minus 1 by 2 per x into cos e power minus x plus e power minus x sine e power minus x into dx. Here the variables are separable. So let's perform integration. Let f of x equal to cos e power minus x, then f dash of x will be derivative of cos e power minus x is minus sine e power minus x into inner derivative of e power minus x is minus e power minus x, which gives us minus into minus plus, so you'll get e power minus x sine e power minus x, or you can use chain rule. Okay, fine. So here we are going to apply the formula integral e power x of f of x plus f dash of x equal to e power x f of x. Okay, so you're having e power x f of x of f of x plus f dash of x, right? So which gives us e power x f of x, that is e power x cos e power minus x. Integral dA is a equal to minus 1 by 2 into integral e power x f of x plus f dash of x is e power x f of x plus some integral constant, say c1, right? Now let's see chain rule. When we go for chain rule, let f equal to, f is nothing but f of x, okay? F equal to cos e power minus x, and let e power minus x equal to some t. Now we are going to apply chain rule to find f dash. Df by dx can be written as df by dt into dt by dx. Now we need to find dt by dx and df by dt. See, we have considered e power minus x as t, then we'll get f equal to cos t, right? Now differentiate on both sides with respect to t, then you'll get df by dt equal to derivative of cos t with respect to t is minus sine t, right? And here you're having t equal to e power minus x, we need dt by dx, so differentiate on both sides with respect to x. You'll get dt by dx equal to derivative of e power minus x with respect to x is minus e power minus x. Now coming to the formula, f dash equal to df by dt is minus sine t into dt by dx is minus e power minus x. Since we know that t is e power minus x, so let's replace this t by e power minus x. We'll get sine e power minus x into minus e power minus x, which gives us minus into minus plus e power minus x sine e power minus x. See, we'll get f dash equals to, or f dash of x equal to e power minus x sine e power minus x. You'll get the same thing. Okay, either you can find directly the derivative of cos e power minus x like this, or you can apply chain rule and apply this formula to evaluate this integral. See, you'll get e power x of f of x, which is cos e power minus x, plus f dash of x, which is e power minus x sine e power minus x, is e power x f of x, that is cos e power minus x plus integral constant is c1. We'll get the same answer here. Okay, we'll get a equal to minus 1 by 2 integral e power x f of x plus f dash of x is e power x f of x plus some integral constant, say c1, right? So we got a here. Therefore, a equal to minus 1 by 2 e power x cos e power minus x plus c1. We got a. Let's now find b dash and b. B dash is given by u into r of x by uv1 minus v1. U e power minus x, r of x is e power minus x sine e power minus x plus cos e power minus x by uv1 minus v1 is 2. Can write this as 1 by 2 into e power minus x of e power minus x sine e power minus x plus cos e power minus x, or you can write this as 1 by 2 into e power minus x sine e power minus x plus e power minus x cos e power minus x. So we got b dash. Therefore b dash equal to 1 by 2 into e power minus x sine e power minus x plus e power minus x cos e power minus x. Let's now find b using this b dash. We have b dash, and b dash is nothing but derivative of b with respect to x. RHS remains the same. Okay. Now let's separate the variables by taking differential dx to RHS. We'll get db equal to 1 by 2 of e power minus x sine of e power minus x plus e power minus x cos e power minus x into dx. Here the variables are separable, or you can include one more step. db equal to 1 by 2 into e power minus x sine of e power minus x dx plus e power minus x cos of e power minus x dx. So here the variables are separable. So we can perform integration. Integral db equal to 1 by 2 into integral of e power minus x sine of e power minus x dx plus integral e power minus x cos e power minus x dx, right? Let e power minus x equals to some t. Now differentiate on both sides with respect to x. We'll get derivative of e power minus x with respect to x is minus e power minus x equal to dt by dx, which gives us minus e power minus x dx equal to dt, or e power minus x dx equal to minus dt, right? Now we can replace e power minus x with t and e power minus x dx by minus dt, right? Then this equation becomes integral db equal to 1 by 2 into, you can include one more step here, okay, for our convenience. Integral e power minus x sine e power minus x into e power minus x dx plus integral cos e power minus x into e power minus x dx, so that we can replace e power minus x dx by minus dt in the next step. This gives us integral db equal to 1 by 2 into integral, replace e power minus x by t, we'll get t sine t. E power minus x dx can be replaced by minus dt plus integral cos t into minus dt, which gives us integral db equal to 1 by 2 integral of 1 by 2 of integral or minus integral t sine t dt plus into minus integral cos t dt. Now let's evaluate integral t sine t cos t or x sine x dx for our convenience. Okay, instead of taking variable t, we'll consider x. Integral x sine x dx. So here we are going to apply integration by parts formula. Integral u dv equal to uv minus integral v d. The integrand is of the form product of polynomial and trigonometric functions. Consider the polynomial function as u and the remaining part as dv for our convenience. Not convenience, this is just a formula, right? We have u equal to x and dv equal to sine x dx. Now differentiate on both sides with respect to x. We'll get du by dx equals to derivative of x with respect to x is 1, which gives us du equal to dx. And here integrate on both sides to find v. We'll get v equal to integral sine x dx is minus cos x. Now apply the formula. Integral u dv equal to uv, u into v minus integral v into du dx. This gives us minus x cos x minus into minus plus integral cos x dx, which gives us minus x cos x plus integral cos x dx is sine x. Therefore, integral x sine x dx is minus x cos x plus sine x. This is for variable x. So take it for variable t. You'll have t sine t dt equal to minus t cos t plus sine t. Now coming to the equation, the above equation. Since integral t sine t dt equal to minus t cos t plus sine t, the above equation becomes integral dv be equal to 1 by 2 of minus integral t sine t dt can be replaced by this result. We'll get minus of minus t cos t plus sine t minus integral cos t dt is sine t plus some integral constant, say c2. This gives us 1 by 2 into minus plus t cos t minus into plus minus sine t minus sine t plus c2, which is equals to 1 by 2 into t cos t minus sine t is minus 2 sine t plus c2 is equals to 1 by 2 t cos t minus 1 by 2 into 2 sine t plus c2. Here 2 gets cancelled and you'll get 1 by 2 t cos t minus sine t plus c2. Now you can replace t by e power minus x. Since t equal to e power minus x, this equation becomes b equal to 1 by 2 e power minus x cos e power minus x minus sine e power minus x plus c2. Therefore, b equal to 1 by 2 e power minus x cos e power minus x minus sin e power minus x plus c2. We got a and b. Let's now find the general solution using y equal to a e power minus x plus b e power x. Therefore, the general solution is given by y equal to a e power minus x plus b e power x. Substitute a and b. Minus 1 by 2 e power x cos e power minus x plus c1 into e power minus x plus b 1 by 2 e power x cos, it's minus x, right? You'll get minus here. Cos e power minus x minus sin e power minus x plus c2 into e power x. This gives us minus 1 by 2 e power x into e power minus x cos e power minus x plus c1 e power minus x plus 1 by 2 e power x e power minus x cos e power minus x minus e power x sin e power minus x plus c2 e power x. See, e power x e power minus x is repeating twice. See, here you can cancel minus 1 by 2 e power x e power minus x cos e power minus x plus 1 by 2 e power x e power minus x cos e power minus x here itself, or you can replace e power x into e power minus x by 1, since e power x into e power minus x is e power x into 1 by e power x, where e power x gets cancelled and you get 1, right? So let's replace e power x and e power minus x with 1. That is the product of e power x and e power minus x by 1. You'll get minus 1 by 2 into 1 into cos e power minus x plus c1 e power minus x plus 1 by 2 1 into cos e power minus x minus e power x sin e power minus x plus c2 e power x. You can write this as y equal to minus 1 by 2 cos e power minus x plus c1 e power minus x plus 1 by 2 cos e power minus x minus, it's minus, okay, e power x sin e power minus x plus c2 e power x. So here you can cancel 1 by 2 cos e power minus x, that is minus 1 by 2 cos e power minus x, and plus 1 by 2 cos e power minus x gets cancelled. This gives us y equal to c1 e power minus x minus e power x sin e power minus x plus c2 e power x, or you can write this as y equal to c1 e power minus x plus c2 e power x minus e power x sin e power minus x. Therefore, y equal to c1 e power minus x plus c2 e power x minus e power x sin e power minus x, which completes the problem. So we have seen a problem from variation of parameters method in this video. I hope you will understand. We'll see you in the next video. Until then, bye bye.